In this example, this is problem number 5 from section 2.1, and we're asked to graph y is equal to the quantity x plus 3 cubed plus 4. So keep in mind that since the exponent, the largest exponent is 3, this is a cubic function. So we're going to graph using this cubic function tool. But first, before we graph, let's explore the cubic function. And for the cubic function, we have its basic form as y is equal to x to the third power. And it forms what is called an S-shaped graph. If we have this general form, y is equal to negative x cubed, it forms what's called a reverse S-shaped graph. Notice that for our equation, we have y is equal to the quantity x plus 3 quantity cubed plus 4. Since the value of our x variable is positive, we're going to have this S-shaped graph. Also, when we take a look at cubic functions, we have what is called an inflection point. And an inflection point is where the graph changes from either concave up to concave down, or from concave down to concave up. When we talk about concave up, a concave up graph will actually hold water if you pour it into your graph. A concave down graph will not hold water. So we can see from this first graph y is equal to x cubed, it changes from concave down to concave up. This inflection point is actually found at the value h comma k. So h, and we have k. So keep in mind from the lecture on cubic functions and quadratic functions, the h variable will change sign. So the inflection point here would be negative 3 comma 4, which is the first point that we're going to use in our graph. So if I go back to the question, I'm going to check the cubic function, and we're going to use that inflection point, which is negative 3 comma 4. To choose the other point in our graph, so notice that our graph is actually going to be an S-shaped graph. I want to choose a point above or greater than negative 3. So here for our example, I'm simply going to choose negative 2. So just to show how this works, we have the function y is equal to x plus 3 quantity cubed plus 4. So what we're actually doing is we're making an x and a y chart. When we substitute x for negative 3, we should get a value of 4, which is our inflection point, and that can actually be pulled from the graph, but I'll show the math behind that. And we're also going to take the next point above, which is negative 2. Okay, we're simply just going to plot these 2 points using that cubic graph tool. So we have our function y is equal to the quantity x plus 3 cubed plus 4. We're going to substitute x for negative 3. So wherever we see a negative 3 in our function, we're going to substitute for x. So when x is negative 3, y is equal to 4. I'm also going to substitute in negative 2. So here again, wherever we see an x, we're going to substitute for negative 2. So I have to simplify what's in the innermost parentheses. Negative 2 plus 3 is a positive 1. 1 cubed is 1. So when x is equal to -2, y is equal to 5. So we're going to plot that point -2, 5. So we're going to plot -2, 5, and that should be our graph.